Hi, Calculus. Well, you can see that I'm at home and you're at school. So I'm not under quarantine yet, but just waiting some test results for a family member. So who knows what we'll get after this. What I've done for you today is I have a video of some common questions off of worksheets 9, 10, and 11 in Chapter 1. So I picked out questions that I thought would be asked and went through some explanations of those. So you guys can get out those worksheets and kind of follow along, correct those. If there's any other questions that you have, if you email me during school, I'm going to make another video to post up on Schoology for tonight. There will be a short quiz tomorrow. It's not going to be a chapter test. So we'll have the kind of basic understandings, and I went through a few limits today too to help review some of those. All right, get out those worksheets and enjoy going over some of the homework with me. All right, I hope to see you tomorrow if everything turns out well. If not, I'll see you after fall break.
Let's start with worksheet 1.9. I've got questions on 2, 5, 6, and 12 that we'll do together here. So as we go through this, check what you have written on your worksheets, correct them, use this to help on any others. Number 2, these we have to verify if the EVT applies and verify if IVT applies and find that value of C if it does. So the first part, real simple. Remember, what we're doing to verify is just explain the conditions, not prove them, just explain them correctly. So for EVT, remember, all we have to know is it continuous? That's our question. That's what part A is really asking. And it only has to be continuous on the interval. So to verify, all we have to write down is f of x is continuous on the interval 0 to 3, because this is a polynomial. Polynomials are continuous. We don't have to worry about things like that until we get into fractions and stuff. So polynomial, that's enough to say it is continuous. You don't have to do a proof or anything. So f of x is continuous on 0 to 3. So our conclusion, EVT applies to this situation. That would just be like saying it's continuous, so we'll be able to have a maximum and a minimum value on there somewhere. Okay, didn't ask us to find it though, that's for later. Part B then is, again, verify that IVT applies, and if it does, then find that C value that it guarantees will happen. So for part B, 2 parts, remember. So the first part is the same thing that we just did here. So I'm going to write them both down just for the individual problem here. Step 1, or the first condition, is that we can say f of x is continuous on 0 to 3. Okay, write down that statement. That's 1. Check that off. So that statement is the first part. If it's not continuous, say it's not continuous, so you can't do the rest of the problem. It will not apply. Okay, so f of x is continuous. We're verifying that it works. Second one, remember, is we want to get a negative 3y value. So we got to make sure that is between the y values at the ends. We're guaranteed all the values between will happen. So second part is we're going to show that, and that's by doing f of the ends. F of 0 is, so plug it in, 0 minus 0 plus 0 minus 2 is negative 2, and f of 3, the other end in our interval. That is 27 minus 9 plus 3 minus 2, just doing a little bit in our head there. That ends up with 19. So we want to get a negative 3. We are checking, is negative 2 less than negative 3 less than 19? Is negative 3 between those? And it doesn't look like it. That is not the case. So because of this, we have shown that it is not between there. The IVT does not apply. So if it doesn't apply, we are not going to waste our time going through a solution trying to find where this equals negative 3. It might somewhere, we might get lucky and it does, but we can't guarantee it. So negative 3 is not within the boundaries that we are we are guaranteed to look between. Okay? So those are the two things we're going to check off. This one, second one, did not work. But that's how we show each. Just a statement about continuity and showing the actual values that you're going to look between. Number 5 I picked out. So this one, we have a fraction, a rational function. So the first thing we have to do is we'll kind of do the first step together for both of these. Step 1 is continuity. Now let's take a look at this. It factors x minus 4, x plus 4 on top, x minus 4 on the bottom, and reduces. There is a hole, a removable discontinuity at x equals 4. So we found a discontinuity on this one. Let's see about that first check that we have to make on both of the theorems. So we are supposed to check continuity, but remember, we are only checking this interval 0 to 2. 4 is not in 0 to 2. So that means we don't care about it. So we can make the first statement and say f of x is continuous on the 0 to 2 interval. So f of x is continuous on 0 to 2. We can keep going. We don't care about what's happening at 4. So we can go to the next one. You might hear my dog barking in the background. Let's go to second step. This means EVT does apply, so we can automatically see that EVT, yes. So let's go on to the second step for IVT. We need to show that our value is between the ends. We need to do f of 0 and f of 2 to see if 5 is between there. So 5 is the value we're looking for. F of 0 now, we reduce this. You could actually just plug it into x plus 4. That's what's left. 0 is going to be 4. Plug it in the whole thing. You get negative 16 over negative 4 is 4. F of 2, 2 plus 4 is 6. Same thing if you plug it into the beginning. As long as you're not plugging in where the hole is, you're good to just plug it into the reduced form of x plus 4. So we are going to check is 5 between lower to higher, 4 to 6. That works. So that means IVT will guarantee something happens. So IVT applies. Applies. So let's keep going then. We've got both things. IVT applies. So now it said, if possible, try to find that C. And all that means is we want to find where 5 gives us an x value from this function, this x squared minus 16 over x minus 4. Where are we going to get that value? What x value? Or that will be our C that we're looking for. Now, we can solve this. Multiply, combine like terms, you're going to get a quadratic. It'll be like 5x minus 20 equals x squared minus 16. That is x squared minus 5x plus 4. That factors x minus 4, x minus 1. So the x values we can consider are 4 and 1. And remember, we don't have to have two solutions. You could find many. We're guaranteed one, but it has to be in the interval 0 to 2. Okay? In the interval 0 to 2, that means our C value will be the 1. We don't need the 4. The 4 is not between it. That's not the one we're guaranteed. So the C value we're guaranteed is 1, the X value on this case. Now, remember we reduced this fraction to x plus 4. We could have just done up here 5 equals x plus 4 and got x equals 1 right away, since it is the same function everywhere but that hole. And so you can take little shortcuts like that. All right, next, number 6, using IVT, explain why the function has a 0 in the specified interval. So this one has a trig function. I figured you'd want to see one with a trig function in here. So when it says has a 0, remember what all that means is it's saying, where does f of c equal 0? Is there a place where f of c equals 0? So that's kind of the continuation of this problem. So use IVT to find just our number is 0 over here. So we're going to do the same thing. For continuity here, just to explain why it works using the IVT, we have to explain the conditions. So x squared minus 2 is continuous. Remember, cosine and sine are both continuous. You can think of the graph that just goes up and down and up and down. So that's continuous, no holes, no asymptotes. Those are fine. So the combination of all this is continuous. So f of x is continuous on this 0 to pi interval. And then we want to check to make sure f of 0 and f of pi that we get numbers around 0. Now, 0 is special because we don't actually need the full value of this. F of 0 is 0 minus 2 minus cosine of 0. Cosine of 0 is 1. So 0 minus 2 minus 1 is negative 3. We actually have that value. Pi, here's the problem. Pi squared minus 2 minus cosine pi. Cosine of pi is negative 1. So pi squared minus 2 minus negative 1 is pi squared minus 1 when you combine those. Well, that's a problem. I don't, pi squared, I could estimate what that is, but maybe 3 squared is 9, minus 1 is 8. That doesn't matter. We can just use this to explain because this is positive. Okay, so we could say because f of 0 is negative and f of pi is positive, that's all we really need. 0 is going to be between any negative and any positive. We can say there will be a 0 in that 0 to pi interval, okay, because of the IVT. We've stated that it works and the continuous. Now we're stating that 0 is between these two ends because one's negative, one's positive. So we didn't actually have to get this value as long as we know it's positive. They did not ask you to find C, so we aren't going to. All right, number 12, the word problem with this. So the only difference here is they actually give us several values, but not an equation. So we're just going to use all these values up here. Remember, this is x and y values. So using this table, important words, f of x is continuous on this interval. They just told us that. So can we use IVT to explain? Can we use it? Well, let's check. We've got f of x is continuous on negative 1 to 8, so that's good. They just told us that. And let's see, we're supposed to show that between two y values, 6, our number is between there. So we could use any two that we want that we can find. I could say f of negative 1 is 5, f of 8 is 12, and 6 is between 5 and 12. That checks. You could use a couple others in here too if you wanted to. You don't have to use the endpoints there as long as you find two values somewhere in the chart that are around 6. So one lower, one smaller. So therefore we could say IVT applies. And we will find a place somewhere in here, there's a value that will give us 6 as a y value. Okay. So then it says, can we find that c value? Find the actual value where f of x equals 6. That's our c in here, that x value. So as we look at this, we could narrow this down a little bit more. They didn't specifically ask, but where is that 6 going to happen? Well, somewhere between the 5 and the 12, we already said, between the beginning and end, but we can narrow it down. In fact, if we go from 5 to negative 2, is there a 6 in there? Doesn't have to be. That's not where it is. Negative 2 to 8. There does have to be a 6 in there between those two. We can narrow it down that far. 8 to 12? No. 6 doesn't have to be in there. Could. So can we find the c value? We could say it's somewhere in the 3 to 5 x value range, but we can't find it. So the answer to this one is somewhere there. That's not enough. Can we find the c value? The answer is No. And it's just that we don't have a complete function. Okay. We know it's continuous. They guaranteed it. I could plug in, 3.87 if I wanted to, and I'm going to have an answer because it's continuous. I can plug in every number, but we don't have the information for it. So that's why we can say, no, there's no equation. We don't have complete data or an equation. So those are the things we would need to make sure we know exactly where that 6 happens. Right now, I could just narrow it down to between 3 and 5 somewhere. How many times does f of x equal 6 for part C? We already said at least once in that 3 to 5 range, that 3 to 5 interval. Okay. We couldn't guarantee it anywhere else because that was the only place we could say it's between the y values. So we can say at least one time. And we could even give them more information in the 3 to 5 interval. We can't guarantee it happens other times. It very well could. So we can't guarantee that other information. We are guaranteeing one time because that's how many times we saw the y values surround the 6. So that's what we got. One time, at least one time, 3 to 5. Maybe it happens a lot of times. We can't guarantee it. So at least one. Does EVT apply? It's continuous, so yes, all we had to check was that it was continuous, and they told us that. So what are the extreme values? This is another one where we just don't know, not enough information. The highest value we see is 12. Nothing's saying it can't go above 12 somewhere in here and come back down to 12. So maybe between 5 and 8 goes from 8 to 15 back down to 12. We don't know. So we don't have that information of the equation or the complete data. Let's go to 110 and answer a couple questions off of here. So number 4, you'll see some of the same ideas. I just picked a couple off of this one. So again, what about the EVT and IVT? So here we have the first piece, pretty simple. F of x is a polynomial, so it is continuous on -1 to 2. So EVT, yes, it applies. We explained why. Now we'll just take this over here and say continuous check. For the IVT, now let's find these values. F of -1 and F of 2. So we have to find those. 9 minus -1 squared. 9 minus 1 is 8. Minus 1 is 8. -1 squared. And 9 minus, and we plug in a 2, so that'd be 2 squared. 9 minus 4 is 5. So 5 and 8 are the endpoints. 6 is what we're looking for. That works. So IVT applies. We are guaranteed we're going to find a 6 somewhere in the y values. So now that we're guaranteed, we can try to find that. And that's just by saying 6 equals the equation. Seems like just extra work that we're doing here. Why didn't we just set 6 equal? We're trying to get some of the theory behind this, and that's what some of the calculus does. Okay, why is this going to work? Can we guarantee it's going to work? So now we can just solve this. This one just ends up with x squared. We subtract the 9 and flip it around. It's just 3. So x is plus or minus root 3. But remember, in that -1 to 2 interval, negative root 3. What root 3 is like 1.7 something. So that's not inside here. The positive one is. Our C value is positive root 3. We do have to choose the one that is in our interval. You can't give me both of those. They aren't both guaranteed. So I only need one that's guaranteed, and that's the one. Another word problem here. This one a little bit more relatable, I guess. Sam's height in inches was recorded each year on his birthday. So these are his heights. I guess he was a tall kid. So reported in the table. Explain if the IVT applies. So first thing, they didn't tell us this. Is it continuous? Well, this is a kid growing. So you don't skip right from one height to the next from 45 to 47 inches. You hit every height between. So we could say height, kind of a natural thing, is continuous. Okay. And there's our first statement we checked off. And we can find anything between, let's just look up here. Biggest is 61, smallest is 45. So it will apply for any number between those. So IVT can apply for values between the 45 and 61. We'll just put a Y in there and 61. Okay. So they just ask us if we're going to be able to use it for some values. It's continuous, so height is continuous. Um, can we use it to explain if there was a time when something was 52 inches tall? So what we just said for that one, 52, that would be a yes, because we could just fill that in. 52 is between 45 and 61. So the IVT we already said applies. Since it's between there, we can really apply for that value. It's between the ends, okay? Do we know when that happened? Well, let's take a look. Where does it fit? Now, it's kind of good for us. We just know people who grow taller, at least until they're 11 years old. Uh, so they're getting taller through here. So the 52 looks like it fits right in there, 50 to 55. So we can't give the exact day that was. Kid grew 5 inches in 1 year. He's growing all the time. But 52 somewhere between his 8th birthday and 9th birthday. So we don't know exactly when. So it would be not exact, but during his 8th year, when he was 8 years old, somewhere in there, he was 52 inches tall. Okay, so the idea is somewhere in the 8 to 9 interval is when that was. Sometime when he was 8 years old. And can we use the IVT to say when he was 40 inches tall? Okay, so can we apply this to another number? So this one would be no, we can't be guaranteed that. 45 is not less than 40, less than 61. So that's outside the boundaries. That's the reason why. That little inequality is enough for our explanation. Okay. Now, the kid probably wasn't born more than 40 inches. That would be huge. So it probably did sometime, but we can't use the IVT, the intermediate value theorem, to guarantee that we can have that. Okay. We'll use, regular science and what we know about kids being born to explain that. All right, next. 111. So 111, I've got some limits here for us. This was more review. There's one little IVT at the end of this one. So these are some limits. I noticed on the quizzes, you should be able to see your score from in there. But I wanted to go over some differences again. All right, first page, I gathered these together, 7, 8, and 16. All these are limits to a number. So even though 16 is from the left side, these are all at a number. So limit as x goes to some number, we want to plug in and then see what happens. We could have some good stuff happen. We could have other things like 0 over 0 happen. Let's see. Plug in 9. Square root of 3. Square root of 9 is 3. Minus 3 is 0 over 0. Remember, that means find a way to reduce. I didn't pick the ones that would factor. You can factor on your own. So this one, square roots. When we get the 0 over 0, we change it somehow. We're plugging the number in to get our answer. So multiply by the conjugate on this one, root x plus 3. That gives us x minus 9 on top. You always want to multiply the conjugates together. Look, we already have an x minus 9 on the bottom, so don't mess with it. Just put it next to the root x plus 3. You can reduce, and now we will do the limit again, which just means plug in the 9 to what's left, and what's left is 1 over root x plus 3. That'll be 1 over 3 plus 3 is 6, so we end up with 1/6 as our solution. So let's try it on number 8. Number 8, you plug in 1 over 0 plus 1 minus 1. Well, that is 0 over, the bottom is 0, 0 over 0. This doesn't factor. You can't use a conjugate. Just look at the problem and see how you could simplify it. There's a complex fraction here. So let's do what we do with complex fractions. Multiply by the denominator. that ends up with 1 minus, this one cancels, 1 times x plus 1. Don't forget that there. X plus 1 over, and this is x times x plus 1 down here. That all comes out to be, let's see, 1 minus x minus 1 is just x over x times x plus 1. And you can reduce, and once we reduce, do the limit again. So 1 over x plus 1. The reducing is what gets rid of the zeros. So now plug in our number, our 0 again, and we get 1 over 1, which is 1. And there's our answer. So we could simplify complex fractions to do that, whatever you need to do to make it reduce. Now, with 16, 1 from the left, remember, just plug in 1 to see what happens. Okay, if we get a nice answer, that's going to be the left and right side. So let's see what happens first. Plug in 1. We get 1 plus 2 is 3 plus 1 is 4 over 0. Now we ran into something. Okay, over 0, think through it here. Over 0 is a vertical asymptote. Vertical asymptote. We need to check the exponent, and x minus 1 is a first degree, so that's an odd exponent on there, which means the full limit would not exist. One side is up and one side is down. So let's see which one is which. We have a couple ways to do this. Really, we have a lot of information here in this 4 over 0, but we want to know x goes to 1 from the left means a little less than 1. Let's try 0.9. Now, really, the numerator I don't really care about. It's going to be close to 4. So I'm going to say it's 4 over, even though it might be 3.9 or something. It's close enough to 4. Over 0.9 minus 1 is a negative 0.1. Remember, all we really care is positive on top, and now we have negative on the bottom. So that means this side of it is a negative value. So that side of this vertical asymptote goes to negative infinity. Remember, the 4 over 0 with a first power, an odd power, means one side is up, one side is down. We just found out the left side went down, and the right side must go up. Okay, so don't just stop with 4 over 0. Figure out what each side is doing. You just plug in a number. You could do a number line chart on this one. It'd be a little bit more difficult with that numerator, but you could get it done that way. But plugging in a close number just to determine the signs is all we need. So now, trig with numbers. You might remember 17 first here. This we have this x goes to 0, and one you were told to know was sine x over x is 1. Okay, this is almost the same. So at 0, even though it has this plus, let's just try to do 0. Remember, it came out to be the ratio with these two. So this answer is 4/5. It wouldn't matter if that was 0 plus, 0 minus. That is just the answer for 0. So both of these would be the same thing. So 4/5. Always just try the number first to see if you get an answer. On that vertical asymptote, we didn't get an answer, so we had to do more investigation. So number 10. This one, if you plug in 0, you get 1 minus cosine of 0 is 1. That's 0. Sine of 0 is 0. So there's our 0 over 0. This one is a little bit tricky. There's no way to really simplify what's going on here. We can't factor it. It's not squared, so we can't use a Pythagorean identity. Here's what we're going to do. Remember I said over here, sine x over x gives us 1. That also worked for the reciprocal, x over sine x. So what if we did this? The limit as x goes to 0. I'm going to split this up into two fractions multiplied. One of them is going to have sine x on the bottom. The other one is going to have the 1 minus cosine x on top. We are allowed to multiply the same thing on top and bottom. If I had x over sine x, that would be good. That limit is 1. If I put an x on the top, I need an x on the bottom. This is what we're going to do. Split it up into two limits by multiplying by that extra piece. X over sine x and another limit of 1 minus cosine x over x. This first one was 1. The second one, if you remember, we haven't used it as much, was 0. So we end up with an answer of 0. That one was a little bit trickier, more than would be asked on a quiz or test. You should know the ratio idea on 17. Number 19, now the difference here, not numbers anymore, x goes to infinity. This is end behavior. Horizontal asymptote rules. One common mistake I saw was giving limits as x goes to a number and trying to use horizontal asymptote rules. So real quick review on these two. 2x over 3x, same degree ratio of the coefficients. Okay. The next one we have pretty similar idea here. 2x to the first over 3x, bigger in the denominator. Denominator is bigger, horizontal asymptote rules for the infinity. This one is automatically 0. Okay. There wasn't another one on here like this, but just to recap, if I give you the limit as x goes to infinity, what if the top is bigger? 4x cubed minus 2x plus 1 over 2 minus x. Okay. Lead terms, minus x and 4x cubed. Bigger in the numerator is some kind of a slant asymptote. You do not have to do the full division. Just do 4x cubed over negative x. That's negative 4x squared, and that is a parabola that goes down both sides. So that would be a negative infinity. The right side is down. So just look at the lead term, and that's the polynomial rules. Types of discontinuities on each question, each function. This one, we have to check 3. So if we plug it into each, 2 times 3 minus 5 is 1. Negative 1 over 3 minus 4 is negative 1 over negative 1 is 1. There is no jump. It has an equal sign. There is no hole. That means as far as 3 goes, it's continuous. Don't forget about each individual equation. This one has a vertical asymptote at x equals 4, and check, it works. That is bigger than 3, bigger than where the equation shows up. So that is our only discontinuity we need. Make sure you check the equations separately on their own. And last one, we've done a couple of these already here. So verify if it applies. If so, find the value of c. So polynomial, it is continuous. Okay, f of x is continuous. Check. Find each end. F of 1 is 2 minus 3 is negative 1. F of 2 is 2 times 8 minus 3 is 13. It went from negative to positive, so of course there's a 0. Negative 1 less than 0 less than 13. Check. It applies. So now, can we do 2x squared minus 3 equals 0? We can. 2x squared equals 3. X squared is 3 halves and square root. So we have a choice of plus or minus square root of 3 halves. Remember, you have to give me one that applies. So is that in 1 to 2? Okay. 1.5 is what 3 halves is. Square root of that is bigger than 1, less than 2. So C is positive square root of 3 halves. The negative one, not in there. That's not negative. All right. I am posting the answers for 112. That's your review. There will be a short quiz. It won't be a full test tomorrow. We're just going to do a shorter quiz on some of this information, like showing this IVT and a few review limits. That's what's coming up tomorrow. So do 112. Make sure you get all of those turned in. All right.